The other thing that we're going to focus on now is selective breeding, so that we can compare that to what we've just learnt about natural selection. And what we want to know is, what do they have in common? What's different about them? Are they really all that different? So our third video after this one will be about summarising what they have in common. But to start with, we'll just sequence through how it works. And I'm not going to write quite so much in this one, because there are a few similarities. Selective breeding, in a nutshell, is where humans have created breeds of a particular species that suit their needs or wants. So, for example, with dogs, probably, I infer here, but probably the runts of wolf packs have been shunned by their pack and found food and comfort with humans. They were the milder wolves because they were the runts, and humans saw them as being good company, possibly good protection, because they still were quite aggressive animals. And so through time they were domesticated, and then some differences in the wolves that they domesticated were noticed and selected for. It made them better for fetching, for example, because a wolf won't fetch, it'll just chase. Things like gentler nature, so be around families, and so on. So some of those characteristics were noticed, and they were bred for certain things. You start getting the ones that are the guard dogs, the more aggressive ones. You start getting the hunting dogs, the ones that chased and retrieved things, so the ones that had that fetching behavioural adaptation. And you had the ones that were the dogs that were just left at home with the kids because they were very gentle natured. And then from that you get the ultimate of what we have now, which is our variety of dog breeds from that one species. They're still the same species, but humans have selected phenotypes and characteristics that they like, bred those individuals together, even if they're from the same family, even if they're from the same litter, to make a breed that suits their needs. Another example would be something like with tomatoes, where you'll know there's a variety of tomatoes, different flavours, different sizes and so on. They all come from an original tomato plant, but over time humans have selectively crossed different tomatoes that have come from that original tomato breed, as it were, to make the variety we've got now. And I suppose one of the other really big obvious ones is the cabbage family. The native cabbage plant you wouldn't eat. In fact, some would say you wouldn't eat cabbage anyway, but the original cabbage you wouldn't eat. But from the cabbage plant, same species, we get broccoli, cauliflower, red cabbage, normal cabbage, Brussels sprouts, just to name a few. And then you can cross those together to make other interesting vegetables that have got characteristics of both. Again, humans using selective breeding to make those breeds. So how do we do that? Well, it has actually come from observing natural selection that humans have done selective breeding. By noticing that individuals with certain characteristics, when they have the opportunity to undergo sexual reproduction, the offspring have some characteristics from both. And usually these stronger or more favourable characteristics of both are combined. So that's the observation that's led to selective breeding. So where does that variation come from in the first place? Well, just like in natural selection, you're starting off with random mutations. So you start with, just by pure chance, there's some difference in a population. Then you've got a selective pressure. Just like in natural selection you had a selective pressure that was the environment, now these random mutations which have led to new phenotypes and new alleles you've got them being selected for, so they are now being bred for those. But the selective pressure this time is not nature. Instead of it being an environmental pressure, the pressure is what do the humans need or want? What do the humans need or want? And this creates our different breeds. one of the big points here is it's not making a new species. We call them subspecies, if you want to be scientific about it, but in everyday terms we call them breeds. So basically your cauliflower, your red cabbage, your normal cabbage and so on are all breeds of the cabbage plant. Okay? I think in agriculture they call it a cultivar, alright, where it's a different type, but it's actually still the same species. So new breeds, they're not new species. Alright? However, you could argue that maybe in dogs, if I use that example, that you have got a new species, because there's no way a chihuahua could cross with a wolf. The wolf would probably eat the chihuahua first. But using that example, I'm going to have a look at what's different about selective breeding. Selective breeding is creating things that suit our needs and wants by basically doing a lot of inbreeding. So this one relies on inbreeding. There are inherent issues with inbreeding. Inbreeding can lead to recessive alleles being expressed more often. Now that's really good when those new alleles and new phenotypes have been created by random selection, because the bets are they're going to be recessive alleles. So we want the new organisms, the new breed, to express that phenotype and not have the dominant phenotype dominant allele in their gene pool at all. So that's really good. The problem is there's quite a few genetic diseases, I suppose I could call them, so negative mutations, which are also recessive alleles. If those happen to be present in your starting population of your new cabbage plant or your new tomato plant or your new dog breed, then every one of those purebred dogs, purebred tomatoes, purebred cauliflower, cabbage, whatever, they're all going to have that genetic disease, because you've created, by inbreeding, you've created a pedigree, a family tree that has that allele being expressed as well. So that's a bit of a negative about this. The chances of this happening in natural selection is very, very low, because that's a negative. The environmental pressure would select against it. It would kill those off as a family. Alright? So just be aware there's a big difference here. One, you're making new breeds. This is not a driving force of evolution, although maybe you could argue it is. And this relies on inbreeding. So there's a bit of a difference. Okay, stop there.